In this second video in the series of organic chemistry, we will be discussing the nomenclature of hydrocarbons. Specifically, this video will cover nomenclature of alkanes and cycloalkanes. Now, in the early days of organic chemistry, new compounds were given names based on their origin or their molecular shapes. For example, limonene was shaped very similar to lemons. Cuban had a cube shaped. But today, because of the sheer number of organic compounds in existence and the ones being synthesized each year, a systematic naming system needed to be devised. And so we will be looking at the IUPAC naming system. Occasionally we will discuss the common naming system, but we're going to stay real basic with just simple IUPAC rules, beginning with the simplest hydrocarbons, the alkanes. Now, through this video and through the next couple of videos, we will be focusing on the main functional groups. And this video will be covering the alkanes. And if you do remember that alkanes are saturated chemical compounds where they have single bonds only, each carbon holds the maximum number of hydrogens that it can hold. Now notice that each carbon has 4 lines coming off of it because each carbon forms 4 covalent bonds. In the upcoming videos, we will cover the alkenes. The alkenes have double bonds, and it's indicated with the double line here, and they are unsaturated because if this bond breaks, they could hold additional hydrogens. The alkynes, which have triple bonds represented by the 3 lines here, are also unsaturated. And then we have our aromatics represented by our benzene ring. In future videos, we will be looking at the various functional groups and basic nomenclature associated with the functional groups. While naming hydrocarbons, the first thing one needs to be aware of is the prefixes associated with the number of carbons. Now, I have the number of carbons from 1 to 10 laid out here, and our prefix, now when we do the prefix, you just need to take off this end right there, because these are the names of the first 10 alkanes. And so when we look at this, our prefix for 1 carbon would be meth, our prefix for 2 carbons would be eth, 3 carbons would be prop, 4 carbons is bute, not but, 5 carbons is pent, 6 carbons is hex, 7 carbons is hep, 8 carbons is oct, 9 carbons is none, and 10 carbons is dec. So I would write this on a piece of paper, and I would be aware of these prefixes for the number of carbons 1 to 10. The A and E needs to be removed, as these are naming of our first 10 alkanes, and we'll discuss how we knew that these were alkanes and the structure a little later on. So when we begin looking at the nomenclature of alkanes, again, there's 2 general types of nomenclature. There are the trivial names, such as acetone or acetic acid, and there are the IUPAC names, which is like propanone or ethanoic acid. Now, we will be reviewing over the IUPAC names. The IUPAC names are the names that have step-by-step rules for naming. The trivial names are the names that you just have to memorize. And so if your professor expects you to know, for example, acetic acid, they'll tell you the ones to know. Otherwise, you will be expected to know the names based on the IUPAC system. Returning back to this chart right here, if we were to look at this chemical compound right here drawn out, we have CH4. Now, this is a structural formula, and this is the molecular formula. And what we really like to do is to see it drawn out. So a CH4 would be C with 4 hydrogens attached to it. and you can see that there are only single bonds present, and because there are only single bonds present, this is an alkane. So the first thing we do is when we look at a chemical compound, we determine does it have single, double, or triple bonds present. This having single bonds only, it would have an ANE ending, and that's where we got this ANE ending. To name the remaining part of the chemical, we look at the number of carbons. There's one carbon here, and so if we go back to that chart we gave you that had one carbon has a prefix of meth, this chemical would be a meth. It's single bond, so ANE, it would be called methane. Now if we had a 2-carbon compound, and we had carbon attached to carbon, and then we had a hydrogen and a hydrogen and a hydrogen. Now I know the number of hydrogens because each carbon must be bonded in 4 places. And so when I look at this, I see my carbon is attached to another carbon, so there's 1 bond, there's 2, 3, 4. And so I look at this, and when I'm looking at do I have double, single, or triple bonds, I'm looking at the bonds between the carbons. The hydrogens will always have single bonds only. So I have a single bond here that gives me an ANE ending. I have 2 carbons. Prefix for 2 carbons is eth, so this chemical compound would be ethane. I would continue down the list. For 3 carbons would be propane. For 4 carbons, butane, 5 pentane, 6 hexane, 7 heptane, 8 octane, 9 nonane, and 10 decane. So that's easy enough, but what if I have something extra coming off? How do I name that? The first thing I want to do is I want to count my longest carbon chain when I'm naming my hydrocarbons, and that's the longest chain that I can cover without backtracking or without lifting up my pen. And so as I count this, I have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. It looks like this right here is my longest chain with 8. So my prefix for 8 is oct. I have single bonds only in between my carbons, so I have an ANE, so I have an octane. Now I also need to cover this right here. This is a little chain coming off of this large chain. And to indicate that this is a little chain, we're still going to use a prefix for the number of carbons. So we have 2 carbons, prefix eth, but because it's a little chain, we will have a YL ending. We call this ethyl, the eth meaning 2 carbons, the YL little chain coming off of the large chain. So we have an ethyl octane. In addition to this, we need to indicate where this little chain came off of. Did it come off of carbon 1, 2, 3, 4? And so the way we do this is this could be carbon 1 or this could be carbon 1. We can count from either directions. We could not have this as carbon 1. One of the ends must be carbon 1. Now if this is carbon 1, I have this chain coming off of the 5th place. But if this is carbon 1, I would have this chain coming off of the 4th place. And I want my chains to come off of the smallest carbon number possible. So this is carbon 1, and so I would have this little chain coming off of carbon 4. So I would say 4, telling me where the little chain came off of. Ethyl, telling me the little chain is made up of 2 carbons. Octane, telling me that this is 8 carbons long. What if I have more than one little chain coming off of that big chain? Well, then I'm going to use prefixes. If the little chains are both the same size, I'm going to use the prefix di. If I have 3 that are the same size, tri. If I have 4, it's tetra. If I have 5, it's penta. So I could have a 3-ethyl 2,4,5 trimethyl heptane. Wow, what does that mean? Well, let's look at some of these on the upcoming slides. Here we have our 4-ethyl octane from our previous example. But let's take a moment and let's look at this example right here. Now if there are two chains of equal length, and if we count this way we have 6 carbons, and if we count this way we have 6 carbons, and we have to pick which chain to use. We're going to choose the chain that has the highest number of substitutes. So if we look at this chain right here, we'll notice that this chain only has one substitute right here. If we look at this chain right here, we'll notice that it has this substitute and this substitute. So the numbering system in the second drawing here is going to be the correct system to use. And so as we look at this, we will count and we will see that we have 6 carbons. So we have the prefix hex, single bonds only, and if you're not sure, go ahead and draw this out to help you. So we would have our carbon, and I'm just drawing my hydrogens like that, and then we're attached to a carbon with a hydrogen, and it has a CH3 right there's my CH3 right there, and then that's attached to a carbon and it has my CH2 CH3 there, and then that has a carbon with our hydrogens and a carbon with our hydrogens, 1, 2, 3, 4, 5, and then a carbon with my hydrogens, and I can see that it only has the single bonds. And if you need to do this, by all means draw this out. But we've drawn it out and we can see that we have 6 carbons, single bonds only, so we have a hexane, and then we need to label these 2 chains that are coming off. Now when we name these chains coming off, if there's more than one substitute group, and we have a substitute group here of 1 carbon, and we have a substitute group here of 2 carbons, then the substitutes are going to be listed in alphabetical order, not arranged according to the number of their positions. So this right here is 2 carbons, and the prefix for that is eth. So we have an ethyl. This is 1 carbon, prefix is meth, YL ending, methyl. And so to name this, this one would go first because E is before M on the alphabet scale. So we would have a hexane. This is coming off of carbon 3. This is coming off of carbon 2. So we would have a 2-ethyl. We would have a 3-ethyl, 2-methyl hexane. Again, 3-ethyl, 2-methyl hexane would be the correct name. We're going to add this hydrogen right there that I forgot to add just a moment ago. Now let's look at this bottom example down here. Now you'll notice that when we look at our longest chain, we have 9, and we can count this with this being carbon 1 and this being carbon 9, or we could count with this being carbon 1 and this carbon 9. Now as we look at it, you'll notice that my first substitute or little chain comes off of carbon 3 here, and it comes off of carbon 3 here. Well, there's also a tiebreaker for numbering the parent chain if our substitutes come off of the same carbon number. We then go to our next substitute. Now this next substitute on this chemical comes off of carbon 4, but on this counting system would come off of carbon 6. So because our counting in this direction has our substitute groups coming off of 3, 4 versus this way that would have it 3, 6, this would be the correct way to number. So we're going to ignore this. We're going to move on over and count with this being carbon 1 and this carbon 9. We have 9 carbons, single bonds only, so we have a nonane. You will notice that we have 1, 2, 3 small chains to name. This one right here is an ethyl, this right here is a methyl, and this right here is a methyl. So our ethyl is the, E is the closest number on the alphabet, so we would have a 3-ethyl, 4 and 7 are the same thing, so we would have a 4, 7. Because they're both methyls, we're going to use the prefix di. Our answer would be 3-ethyl, 4,7 dimethyl nonane. Now to continue our nomenclature, move to our third video of organics. We do try to keep the videos under 15 minutes. That does help with me loading the videos to YouTube. So we'll see you in the next video.